Hi everyone, a very good morning to all. Now we are going to study about Einstein photoelectric equation. So according to Einstein, light is sum of photons, and when a light falls on a particular metal surface, electron can receive one photon energy, and if that photon energy is sufficient, then electron will come out of it, and that we call it as photoelectric effect. So the very first thing is photon means pocket of energy, and that pocket of energy is equal to h nu or hc by lambda, or you can take it like 12,400 by lambda in angstroms. Then you will get the energy in terms of electron volt, or lambda if you take nanometer 1240 you have to take. And emission of photoelectrons or emission of electrons from the metal using light is called photoelectric effect. Now, if you consider E is the h nu or hc by lambda as photon energy, every metal surface requires a minimum energy that is called work function. Work function means minimum energy needed to remove electron. So that is called work function. So you must give the photon energy such that greater than or equal to pi. And in case if it is more than that, then that will be given to the electron in the form of kinetic energy K maximum. So that h nu minus h nu naught equal to K maximum equal to half m V maximum whole square, or hc by lambda minus hc by lambda naught equal to K maximum equal to half m V maximum square. Here nu naught is threshold frequency and lambda naught is threshold wavelength. Means the wavelength of the photon must be greater than or equal to threshold frequency. Frequency of light or photon must be greater or equal to threshold frequency, but wavelength of light must be less than or equal to threshold wavelength. Then only photoelectric effect happens. So this equation we call it as Einstein photoelectric equation, and K maximum is also equal to EV naught, where V naught is stopping potential, so negative anode potential. So for which negative anode potential the photo current becomes zero, that we call it as stopping potential. So that the equation will become E minus pi equal to EV naught, or h nu minus h nu naught equal to EV naught, or hc by lambda minus hc by lambda naught equal to EV naught. So one equation, different forms. So you have to understand which equation to be used in a particular question. Then the most of the times it always depends on calculation part. Now let's see a few examples based on this equation. Just understand the question and collect the data. One of the important topic. The work function for a certain material is pi equal to 4.2 electron volt. Will this metal give photoelectric emission for incident radiation of wavelength? So for this wavelength, for this one, so now pi equal to hc by lambda naught. So lambda naught equal to hc by pi. Then lambda naught equal to, I can write it as 12,000 for 1240 by energy I will substitute in electron volt, so that you will get in terms of nanometer. So approximately you can calculate it. So 1240 by 4.2. So 12,400 by 42. Now 2 2s are 2 1s are 2 6 2 2 0 0. Now 62 by 21. If you take 3s are, it will become 63. That means it will come around 290 or approximately 300. So that is, it is 290, let's take it. Approximately I am telling. That means the given wavelength is 330 nanometer. Now the wavelength is greater than the threshold wavelength. Then photoelectric emission will not happen. No emission. Because the wavelength of photon must be equal or less than the threshold wavelength. So like that, when you understand the question, you can calculate and you can solve it using the equations whatever we have discussed. Now, the threshold frequency for a certain metal is 3.3 into 10 power 14 hertz. If light of frequency 8.2 into 10 power 14 hertz is incident on the metal, predict the cutoff voltage for the photoelectric emission. So threshold frequency nu naught they have given 3.3 into 10 power 14 and light frequency 8.2 into 10 power 14, nothing but 82 into let it be. Now predict the cutoff voltage. See, H nu minus H nu naught equal to E V naught. So V naught equal to H by E if you take common, nu minus nu naught. H is 6.65 to minus 34 by 1.6 into 10 power minus 19. Now nu minus nu naught, if you subtract 8.2 minus 3.3 into 10 power 14, I can take common. So it is approximately 4. Approximately I'm telling this is, if you take is 5 4s are 20, so approximately 20, so that when you take it goes up, so plus 19 19 plus 14 33 so 10 power minus 1, so that means 2 volt. This is the stopping potential. K maximum, if they ask, K maximum is how much? EV naught. That means, if they ask, that means 2 electron volt. If you know V naught, then that much of electron volt is the K maximum. Now, the photoelectric work function of potassium. So work function they have given as 2.3 electron volt and the wavelength of the light is 2800 angstrom. So that the photon energy will become 12,400 by, so 0 0 cancel. Now, the kinetic, find the kinetic energy in electron volts of the most energetic electron ejected. That means K maximum. K maximum means E minus pi. See, here you will get directly the value in terms of electron volt. Pi they have given in electron volt. Then you will get the answer in electron volt. Just this division is important. So just try to do it approximation as I said 14 and this is 62. Now 62 by 14. So 14 5s are 70. So it is slightly less than that. So it is in between 3 and 4. So 4.5 something will come. So approximately, because here I am taking the descriptive type of questions, but in the examination you will get options. So you check with the options. If the options are not very so closer, then you have to take approximation. Then only you can save your time. And the stopping potential, once you get the K maximum is suppose some X electron volt, then V naught will become what? That X volt, that's it, as I said. Now, if the work function of potassium is, again some work function is given 2 electron volt, then it's photoelectric threshold wavelength. So it's a direct question, as lambda naught equal to 12,400 by pi in electron volt. If you substitute, you will get angstrom. Or if you substitute 1240 and pi in electron volt, then you will get in nanometer. As answer is in nanometer, you just substitute 1240 only. So 1240 by 2 nanometer. So that 620 nanometer. Now, maximum kinetic energy of emitted electrons from the surface of a metal is K. So, general formula for K maximum is E minus pi or H nu minus H nu naught. Now, when frequency of incident light is doubled, the maximum kinetic energy of emitted electrons is K dash. See, first K, that is H nu minus pi. Now, K dash, when frequency became double, 2H nu, but work function remains same. Now, we have to find the relation between K dash and K. Now, what I will do is, K dash equal to 2H nu minus 2 pi plus pi. I just minus 2 pi plus pi nothing but minus pi only. So that K dash equal to 2 if you take common H nu minus pi plus pi. But you substitute this one. H nu minus pi I can substitute as K. So K dash equal to 2K plus pi. So K dash equal to 2K plus pi. 2K plus pi means what? K dash is more than 2K, 2 times K. That is what you can understand. So option A is correct. Like that, sometimes manipulation based questions also they can ask based on the Einstein photoelectric equation. So whatever it is, one single equation, and every time they used to give one question. So please just try to practice. Similar questions I have given as an assignment also, and lot of questions also given in NCRTC. 11 questions they have given. So please just try to understand each and every question and try to solve all the questions. Thank you. We'll continue in the next session with the next class.